Actually happening inside your smartphone charger. Today, we're going to visualize the journey of electricity using a custom 3D simulation. We'll track how dangerous wall power is converted into safe energy for your phone. Let's start the simulation. Ever wonder what happens inside your wall charger? Let's trace the journey of 240 volts of alternating current as it enters the circuit. First, safety. Here we have the fuse, the NTC thermistor to stop sudden current rushes, and the MOV to absorb high voltage surges. Moving forward, the electricity is noisy. We pass through this yellow X capacitor and the green common mode summit choke. They act as a filter, scrubbing out electromagnetic interference so it doesn't leak back into your home's wiring. This stage ensures the charger operates cleanly without disrupting other electronics. Now, the main event, conversion. We approach the bridge rectifier, 4 diodes that flip the negative AC cycles to positive. Then, this large high-voltage electrolytic capacitor stores that energy. We now have about 340 volts of high-voltage direct current stored right here, dangerously powerful. To drop that voltage down, we need to chop it up. This PWM controller chip signals the power MOSFET switch to turn on and off tens of thousands of times per second. This rapid switching creates a pulsing high-frequency AC, which allows us to use a much smaller transformer. That pulsing energy flows into the Flyback transformer. This is the barrier. It physically separates the dangerous high-voltage side from the safe low-voltage side using magnetic induction. Energy jumps across this gap magnetically. There is no direct wire connection here, keeping you safe from electric shock. On the safe side, we step down to 5 volts. This Schottky diode rectifies the high-frequency pulses back into DC, and these capacitors smooth out the ripples. We are almost there. The power is now low voltage, but we need it to be perfectly stable for your phone. But how does the input know if the output is stable? That's the job of the optocoupler. It sends light signals across the isolation barrier to tell the PWM chip to adjust its speed. It communicates using light, maintaining total electrical isolation while keeping your voltage locked at 5 volts. Finally, passing through one last filter inductor, clean, stable 5-volt DC reaches the USB port ready to charge your device. And that is how we turn dangerous wall power into safe energy for your digital life. Thanks for watching.